So in this video, I want to give a very brief proof of what the quotient rule is. So the most important thing to get out of this video is what the definition of the quotient rule is, which is if I want to take the derivative of two functions being divided from each other. Now notice both the numerator and the denominator have to be functions of x. They both have to have an x in them. What I'm going to do is I'm going to take f prime of x first, times g of x. So I'm going to take the derivative of the numerator times the original denominator. Then I'm going to subtract g of x, or excuse me, g prime of x, the derivative of the denominator, times f of x, which is the original numerator. And I'm going to divide that whole thing by g of x squared. Notice it's not the derivative, that is the original denominator squared. Okay, so again, take the derivative of the numerator times the original denominator minus the derivative of the denominator times the original numerator divided by the denominator squared. So again, my goal with this is to try to prove this definition, prove this rule using the limit definition. So I'm going to again start off with just my limit definition of the derivative. So in this case, we're going to take the limit as h goes to 0 of f of x plus h divided by g of x plus h minus f of x divided by g of x. Now, the first thing that I think is going to be helpful, I forgot to divide all that by h. The first thing I think is going to be really helpful in this situation is going to be trying to make a common denominator out of this g of x plus h and g of x. So the trick there again is I want to kind of make a denominator out of this numerator just so I can deal with it a little bit easier. So let me go ahead and do that. Limit as h goes to 0 of, and so this first part is going to need a g of x, so f of x plus h times g of x. Then we'll subtract, and that other fraction needs the g of x plus h. My whole denominator is going to be that g of x plus h times g of x. So notice again, this first fraction got the g of x both times, and this other fraction got g of x plus h top and bottom both times. And then this is all divided by h, or I could actually just move the h up into that other denominator and put it right there. So now this is going to be kind of similar to the product rule formula where I kind of need to do, I'm going to say a bit of a trick. There is a bit of a trick to making this work out nicely. And so what I'm going to do is I'm going to actually, like I did in the product rule video, which is add and subtract the same thing from the middle of that fraction. So I'm going to go ahead and write my denominator down here, g of x plus h times g of x, and I'm still keeping that h down there at the bottom. So let me go ahead and we'll write, that f of x plus h times g of x, and I'll put the minus f of x times g of x plus h back here at the end. Now, again, I want to add and subtract the same thing here in the middle. So I'll do the subtraction first, and then we'll add. And so what I want to do is, again, if I'm looking for f prime of x, I'm going to make this, we'll do f of x times g of x, and then I'll do the same thing back here. We'll do plus f of x times g of x. So here's how this is going to work out nicely. So if I look at the first part of this fraction, I can factor out the g of x part, which is what I'm going to do. So let me write this down. Limit as h goes to 0, and I'll factor out the g of x first. And that should leave me with f of x plus h minus f of x. And I'm also going to go ahead and split up that denominator. So I'm going to put the h with the first, or with the subtraction part, and I'm going to put the rest of that g of x plus h and g of x, I'm just going to kind of put it over here. I'm not going to simplify it simply because I know in the end it's going to have to end up back in the denominator anyways, so I'm just going to kind of leave it alone for the second. And then I'm going to go ahead and do kind of the same thing over here. Now, one of the things I am going to do though is I am going to factor out a negative when I do this so it'll work out nicely. So I'm going to factor out, and I'll make it minus, and we'll factor out an f of x. Now, the way that this should work out nicely, since I'm taking out this negative and the f of x, that makes that a positive g of x plus h, And that'll make, since this was a plus, that'll make it a minus g of x. And again, I'm going to kind of do the same thing. I'm going to split up this denominator. So I'm going to move the h with the subtraction part, and I'm going to keep the g of x plus h and the g of x with that f of x. Now, this should hopefully kind of open some doors again, because I'm looking at it from the perspective of I wanted to find where this derivative would end up being, and it's right there. So I'm going to split my fractions up along this limit line. So we'll do the first part, g of x divided by g of x plus h times g of x. Again, I don't want to simplify that because I'm going to have to recombine this in a minute. Times the limit as h goes to 0 of f of x plus h minus f of x all over h. And again, that's my derivative, so I want to keep that there. And then we'll keep splitting up our limits. So the limit as h goes to 0 of f of x over g of x plus h times g of x times the limit as h goes to 0 of g of x plus h minus g of x all over h. So again, this part right here is f prime. This part right here is g prime. Let me move up just a little bit. So we're going to have the limit as h goes to 0 of g of x over g of x plus h times g of x times the derivative of f of x minus the limit as h goes to 0 of f of x divided by g of x plus h times g of x times g prime of x. Now, as h goes to 0, this x plus h just turns into an x. Same thing here, so let me write that down. We're going to have g of x times f prime of x divided by g of x times g of x minus, again, same kind of idea over here. We're going to have f of x times g prime of x divided by g of x times g of x. And all I'm going to do is recombine that fraction. So we'll have g of x times f prime of x minus f of x times g prime of x all over g of x squared. So hopefully that does help you, again, better understand that these rules don't just come out of nowhere, that we didn't just make them up for no reason, that they are actually, in fact, grounded in reality in this limit definition. Hopefully this helps.